So hello everyone. So in this chapter we will discuss about entity authentication. So I think entity authentication is basically a technique that is designed to let one party prove the identity of another party, and this entity can either be a person, a process, a client, or a server. And secondly, the entity whose identity needs to be proved is called the claimant, and the party that tries to prove the identity of the claimant is called the verifier. So in this chapter we will discuss the topics like data origin versus entity authentication, verification categories, and the entity authentication and the key management. So let us first discuss the difference between data origin versus the entity authentication. So there are two differences between these two. First is that message authentication might not happen in real time, while the entity authentication does. And the second difference is that message authentication simply authenticates one message. The process needs to be repeated for each new message, while in case of entity authentication, the entity is authenticated by the claimant for the entire session, during the entire session. So there are three types of verification categories through which the claimant must identify herself to the verifier. These are something known, something possessed, and something inherent. So something known is basically it is a secret that is known only by the claimant that can be checked by the verifier. For example, it could be a password, a PIN, a secret key, or a private key. Second category is the something possessed. So this is something that can prove the claimant's identity. Examples could be a passport, a driver's license, an identification card, a credit card, or a smart card. And the third category is the something inherent. So this is the inherent characteristic of the claimant. So examples are your conventional signatures, the fingerprints, voice or facial characteristics, retinal pattern, and as well as the handwriting. So let us look at the first category, that is passwords. So passwords are basically the simplest and the oldest method of entity authentication, where the password is something that is known to the claimant. So each user has a user identification that is public and a password that is private, and we can divide these authentication schemes into two groups, the fixed password and the one-time password. So let us see these categories one by one. So the first category is the fixed password. So there can be several approaches. The first approach is that so suppose we have a claimant that is Alice and we have a verifier that is Bob. So what the claimant will do, it will send its password to the verifier, and the verifier will keep a table or a file like this, that is a password file that is sorted by user identification. To access the system resource, the sender sends her user identification and password in the plain text form. So this will send to the system, and the system uses the identification to find the password in the file. So if there is a match, then the access is granted, and if the password does not match, then the access is denied. So this is the first approach. However, there are several attacks that could be done on the first approach, like eavesdropping, stealing a password, accessing a password file, or in fact the adversary can also guess the password. So to overcome these attacks, we have the second approach, that is based on hashing. So this is a more secure approach where the password is hashed in the password file. So a user can read the contents of the file, but because the hash function is a one-way function, it is almost impossible to guess the value of the password. So first, the claimant, that is Alice, will send its identification and password in plain text form to the verifier, that is Bob. Then the verifier will read the hash, will generate the hash of the password and try to match it with the hash that is stored within the password file. If there is a match, then the access is granted, and if they do not match, then the access is denied. So in this kind of technique, it could suffer from dictionary attack. So what happens in dictionary attack? The adversary is interested in finding the password regardless of the user ID. For example, if the password is 6 digits, so if you assume that the password is of 6 digits, then the adversary will create a list of 6-digit numbers, that is from 000 to 999999, and then apply the hash function to every number. This result in a list of 1 million hashes. So she can get the password file and search the second column entries to find a match. And this entire thing could be programmed and run in offline on Eve's private computer. And after the match is found, the adversary can go online and use the password to access the system. So in this manner, the dictionary attack could be performed in this second approach. To overcome this type of attack, we have the third approach, that is based on salting the password. So what happens when the password string is created, then a random string called the salt is concatenated to the password, and now the salted password is then hashed. So when the claimant, that is Alice, first it will send its identification and password to the verifier. Then the ID, the salt, and the hash are stored in the password file. Now when a user asks for access, the system extracts the salt, concatenates the received password, and makes a hash of that result. So this hash is calculated, and then we will match it with the hash stored in the file. If there is a match, then the access is granted, and if there is no match, then the access is denied. And there is one more approach, that is the fourth approach. So this fourth approach, the two identification schemes are combined. So a very good example of this type of authentication is the use of ATM card and a PIN, that is the personal identification number. So the card belongs to the category something possessed, and the PIN belongs to the category of something known. So the PIN is basically a password that enhances the security of the card. If the card is stolen, then nobody could use it unless the adversary is able to know the password. The second category is the one-time password. So one-time password is a password that is used only once, and this kind of password makes eavesdropping and salting useless. And there are three types of approaches that can be used to perform this one-time password. So in the first approach, the user and the system agrees upon a list of password. So each password on this list can be used only once. However, this approach has some drawbacks, like the system and the user must keep a long list of password. And secondly, if the user does not use the password in sequence, then the system needs to perform a long search to find the match. The second approach is the user and the system agree to a sequential update the password. So suppose the user and the system agrees upon an original password P1, which is valid only for the first access, and during the second access the user will generate new password P2, encrypts it with P1, and the key is as the key. Then the P2 is the password for the second access. So in this manner the one-time password is generated. And finally, the most safest way is the third approach, in which the user and the system creates a sequentially updated password using the hash function. So this approach was proposed by Leslie Lampert. So what this proposed is that initially we agree upon an original password, and that is P0, and a counter, that is N, and the system will calculate first this Hn of x, where x is the initial password, and Hn stands for applying the hash function n times. Okay, So in this manner, whenever the system, the user wants to access the system, and that number of times the hash is generated and the password is retrieved. So this is the third approach, that is Lamport one-time password. So Alice will send its identity to the verifier. The verifier will send the N back to the Alice. Then the Alice will compute the hash of N minus 1 time upon the initial password, that is P0. And if both of them match, then the access is granted and the entry within the table is updated, that is N is updated to N minus 1 and the hash is updated to HN minus 1 of P0. So in this manner, this third approach works. Thank you.